Let's start with our first and very essential service in the internet, the domain name system. Without the domain name system, well, nothing would really work. And you see here it's written domain name systems. Well, as I will explain, you could have several. There's a big one, but if you want, you can set up your own. Okay, what is the basic motivation? What do you think? What is easier to remember? A number, an address, or, as you all know, a URL? Well, typically URL is much simpler to remember. Maybe it represents the name of the company, your name, name of a university. So, okay, it's much easier to remember a name compared to, in this case, IP address. Think of the telephone network. Does the telephone network work without any phone book or entries in your smartphone? Well, think of yourself, do you know all the numbers of your friends, for example? So what happens if you don't have access to these entries? The phone network will work. You can still dial a number. So that is no problem. And the same is true for the internet. The internet will work, no matter if you know the names or not. I mean, there are still IP addresses, end systems, links, whatever, they still exist. Even without this kind of a phone book. So the DNS system is kind of a phone book. What else is a motivation? Well, think of a server. A server, you know, so it's your favorite whatever web page, abc blah blah blah.com. Now the company wants to migrate this server into a new network. Well, migration to a new network typically requires change of an address, but you don't want to change the name. It's the same if one of your friends changes the telephone number. You change the entry in the phone book, but you don't change the name of your friend. So we need a system that supports us, for example, for this migration of servers into new networks, for the mapping of these names we all can remember onto these addresses, and many more things. So the main question is, how do we build a system for main purpose name to address mapping? Names to addresses. Well, maybe this sounds simple. Well, it's a kind of a phone book, but we will learn it's not that simple. We need something hierarchical namespaces. We have to manage this because we have millions of names, different so-called zones, servers, a huge database. We need a protocol to exchange entries from this database. Okay, so first of all, what is the key idea? The key idea is we have a kind of a level of indirection. So we want to read a name and say, okay, I want to access this web page, or I want to send an email to some person. So we typically have this person or whatever email address at, and then some name.com. But this, in the real network, this is a computer. The computers, they cannot work with names. Those computers, they have addresses. And here in the internet, they have an IP address. So IP address, not a name. So for us, it's easier to deal with the names. For the network, well, it's easier to deal with addresses. So we have to abstract from the network layer identifier. Network layer identifier, that's our IP address. That was this 129. So it's IP version 4, etc. An application layer identifier, that's our name.com, for example. That's one thing. What else? Well, think of load balancing. So maybe your favorite web page name.com is heavily loaded, so maybe we want to load balance this to different computers or with different IP addresses. This is something such a system with this indirection can support. And we can create an alias. What does it mean? So maybe you have a computer called mailer.name.com, responsible for all the email. But this is a computer you also use for other purposes. Maybe this computer also has a host name called whatever, oslo.name.com. So, same machine, different names. So this mailer is an alias for this real name of the computer. So the real host name. And you can have many more real aliases. So the idea is this indirection does not only help to map names we can remember to addresses, but can also help for load balancing. So there could be 1,000 IP addresses behind Google, for example, and helps for this aliasing. So we can use different names depending on, where you live, for example, or as we will learn, this can also map a well-known name for you, like videos.name.com, to servers of a so-called content delivery network that distributes and replicates the data around the world so that the data is closer to the customer. We'll come back to these ideas later. So what happens if someone takes away the phone book? I told you already, the internet still works, but, and the but is, that's really a big problem. So there's an example, there was a massive outage on the internet, that's what people write. But, it was not an outage of the internet worked, like the telephone network. But someone took away the phone books. So one way of taking away phone books is a denial of service attack, in this case a distributed denial of service attack. Overwhelming so-called DNS servers, I will explain what it is and how this works. The effect was, there was no phone book. And having no phone book has, serious consequences. No one knows the IP addresses of your computers. If you knew the IP address, that you could directly use it, also in your browser. But without the DNS, we don't have the service for our customers. And this is an example of an engineer saying, please, could you do something? Because in this case, something doesn't work for Disney, causing about 20 to 30% of all DNS requests, in this case, asking Google's DNS system to fail. So that means that most of the customers cannot access the web pages of Disney. I will also explain later what this means, that you can use certain IP addresses for the resolution of DNS requests. Okay, so pretty important, such a phone book. So looking back, when did it all start? So this graph shows you on the y-axis, be aware, logarithmic scale, the number of domain names, on the x-axis time. So it all started early 80s, the first RFCs coming out, and then with the first domain names showing up. And it's interesting to see over time things like the .com boom, where you really have a exponential increase, logarithmic scale, you know. This looks linear, no, it's exponential because we have this logarithmic scale. So this was our .com boom. Really, everyone needed a domain name for everything. Then it flattens a bit. But you see several development like, oh, this is not a pure technology question anymore. It says, for example, this RFC, it's up to the requester to be sure that he's not violating anyone else's trademark. Because technically, you can register whatever name, as long as no one else has registered, there is. But in real life, maybe this name is a trademark. So that means you cannot do this. And there were some court rulings saying, okay, domain names are comparable to telephone numbers, bank routing numbers, so they are quite important. So you see, now we have interaction between technology and law, in technology, society, etc. So I was starting some privatization. We have so more and more companies offering domain names, and also some other court rulings saying, okay, domain names can be related to natural and legal persons. So that's quite important. Some more standardization discussions going on, how you handle domain names. I will go into some of the details, and you see what happens if technology goes into societies, company discover the network. I mean, to be honest, the internet existed long time, even without DNS, and not that many people looked into it. But in the mid-90s, it started also with the World Wide Web, and this is exactly when the public and also companies became aware of, oh, there's a cool new technology, and now we had many companies, and as soon as you have companies, etc., you have many dispute cases. In this case, international case where I say, okay, is it allowed to use this and that domain name? What happens if yourname.com is registered by you, but someone else in some other country takes yourname.se for Sweden, for example? Then you as a company wouldn't be happy. If you're a big company like Coca-Cola and someone takes your name in some country and says, oh, that's my domain, then this person can actually attract all the traffic intended for Coca-Cola from this company because people think, oh, this is the webpage of Coca-Cola. So many disputes, etc. Increasing commercialization of the internet, domain names are visible all over the place, and so in the end, DNS and the names became a battleground for trademarks. Okay, so the names, many people needed asked for domains and started selling and buying domains, and so some of the domains became very expensive, and so this is far beyond technology, because now we are really in this field of money, interest, etc. So that's a problem. And then there was also the big discussion of how to open up the system for some more national, let's say, alphabets, different languages, different requirements. I will come back to this. So you see, this is not pure technology anymore, because people, companies, lawmakers, etc. are involved now. But even inside the different institutions handling things in the internet, there are some discussions going on, for example, between ICANN and discussing, okay, what names should be entered in this phone book. We'll have a closer look into the phone book soon. So, and then IETF discussing how to enter something into the phone book and how to read from the phone book. So, and there were also some conflicts, and I will come back to this as well. So, you see, this is not pure technology anymore, so there are some more aspects when we come to DNS. Okay, let's go back to the very basics. First of all, we have two fundamental aspects. One is how to create unique names. So, a name, if you want to enter a name, it should be unique. Now imagine you sit in, for example, here Germany, and you have the clever idea, and no one has done this before. I want to register name.com. And you go to some German registrar, so a company selling these names. There are many of them. And you give some money, and the company tells you, okay, you can take the name. And someone else in the US goes to a company selling domain names, also trying to sell this. And this company also says, yes, you can do this. Sooner or later, this will be a problem because the names have to be unique. You cannot register the same name twice. Will they notice? Well, imagine two different companies. Then sooner or later they will notice. They exchange maybe every other day their databases. That's too late. That's too much chaos. So we have to take care that the names are unique. Okay, so that's one of the aspects. And then we have to take care about how to resolve the names to, for example, an IP address. We will see that we can also resolve names to other services. So DNS is quite powerful. You can use DNS also for resolving a name to a service like this is our mail server. And then we map the mail server onto an address. We will see this. Okay, so very fundamental aspects. The names have to be unique, and we have to take care how to resolve names to a locator or to other services. Then, with another quite fundamental aspects, all this has to scale. Imagine, there are billions of devices, millions of domain names. So, how to handle this? One idea is we have one worldwide database. Okay, and we have all these millions of devices, and all these devices will now ask the database, oh, please resolve this name, resolve this name, resolve this name. You can imagine, whoa, that is a bottleneck. So that doesn't work. And what you always do in computer science, well, then let's replicate. Okay, instead of having this one database, so why not replicating this database and saying, okay, then let's have many databases. Okay, looks much nicer. And then we can balance the request to all these different databases. But as soon as you have different databases, you have to think about consistency. Is this still consistent? How to distribute updates, etc. You have to take care of this. So you have to manage this, and still, do you want to replicate the whole big database of all DNS entries worldwide? This also doesn't work. So we will see we have many databases, and we delegate these requests, but we will not store all the entries in each of the single databases. We will store only parts of it in the databases. Additionally, we use lots of caching. What does it mean if we use caching? That means that even in the single nodes, if they once ask for a mapping of name to address, they will store it internally. And then they will use their cache. The next time they ask for the mapping, they use their internal cache. Sounds great. Caching is one of the tools we always use in computer science. That speeds up processing. But what happens if we perform an update here on one of the databases? Then you have an old entry in your cache. What can we do there? We can live with it. We can perform some updating mechanisms, etc. So yes, to scale a system, we have to distribute databases. We have to use caching, but this comes with a certain price tag. Okay, so how do we do this delegation? And we'll see in the next slides how this is then implemented. One thing is, and that's needed for delegation, is with a hierarchy of names. Hierarchy, you have here a top-level hierarchy, DE, the country code for Germany. Then we have the next hierarchy level, so that's the name of the university, Freie Universität in Berlin. And then the next hierarchy level, that's the server, web server. So for example, we could have more, but important is here, the namespace is hierarchical. And this will help us when delegating tasks. So namespace is hierarchical. This helps especially for the management. So we also have a hierarchy of authorities. So we will see that we have different authorities for this highest level, the top level, another authority for the next second level, and maybe yet another authority for the third level, fourth level, etc. And these authorities are basically the owners of this level. And then we also have a hierarchy in the infrastructure. So we have a hierarchy of DNS servers, also the servers responsible for the highest, the top level, a server for the second level, maybe a server for the third level. So you see, by introducing hierarchies in the naming scheme, we can create a hierarchy in the management scheme. And this is backed then by the hierarchy of the real infrastructure. Infrastructure, where is the mapping stored? Okay, so this was the introduction to DNS. Some questions. So think back, what happens with the internet if there's no DNS? You take away the phone book. What are the consequences? Does it still work? Which part works? Well, what happens? Or maybe even worse, what happens if DNS gives wrong answers? So you have a phone book with wrong entries. What happens then? Then we saw there are names on different levels. Who owns them? Who's responsible that the names are unique? And I mentioned this in the very beginning. What about your own DNS? Can you set this up? What is the reason for setting up our own DNS? And what is needed for setting up an own DNS? Maybe you are able only to answer parts of this question. We will come back to what is technically needed for this.